Hi lads, this morning I'm going to focus on simultaneous equations and also finding if a coordinate is the correct solution for a line in front of us. But before that, I would like to quickly go through an awkward linear equation we have in front of us. We have a fraction, 2x plus 3 over 5, which is equal to 7. Now it asks us in this question to solve the equation, so therefore we need to find the value of x. So in order to solve this, I have to get rid of the fraction. I have a choice. What I can do is I could multiply both sides by 5 in order to get rid of this fraction, because what does this fraction actually mean? It means the equation 2x plus 3 is being divided by 5 on this side. So if I multiplied both sides by 5, I could get rid of the fraction. Or the shorthand way we would have looked at in second year is bring the 5 across, and instead of dividing, we multiply. So this now becomes 2x plus 3 equals 7 multiplied by 5. 2x plus 3 is equal to 35. 2x is equal to 35 minus 3. 2x equals 32. If two x's are worth 32, x is equal to 32 divided by 2. So therefore we get a value x is equal to 16. Okay. You will encounter these questions on your junior cert. You have to be able to solve them. If I look at why I brought the 5 across to the other side, I mean technically what I'm doing there is I'm multiplying both sides by the denominator, which is 5. So I said 2x plus 3 over 5 equals 7. So I'm multiplying both sides by 5 to get rid of this 5 that we're dividing by here. Okay, so therefore that's why I ended up with 2x plus 3 equals 7 bracket 5. So anyways, final answer, x equals 16. Now, what we're looking at today really is this guy. This is called the simultaneous equation. Okay, so we're told to find the point of intersection of the following two lines. Now, it doesn't tell you this is a simultaneous equation, but you should be able to recognize it. So I'm going to write down the word simultaneous equation. So to solve this, we need to put it into the correct format. Okay, you might remember from last year that when we solved simultaneous equations, it looked more like this. Okay, so we had an x and a y, and that's equal to a number. My problem here, though, is that I have x is on the right and y is on the left. So in order to get this to look like a normal simultaneous equation, I need to manipulate it. I'm going to move the y to the right in this equation. So I'm going to start with the first one. So this is this first equation here, which is y equals 2x plus 7. We're going to change that, so y is being moved to the right. So that's y, so we have 2x plus y plus 7. Now I made a mistake there, didn't I? This should be 2x, y goes to the right, so therefore it's minus y plus 7. That's equal to, now if I move the y over to, there's no longer anything on the left, which is going to be 0. So now I need to move the number to the right. We have 2x minus y equals minus 7. And now I have this in the correct format, this particular equation. So I've done equation 1. I now need to do equation 2. So if I look at it, I have y equals 5x minus 11. I think it's a good idea, again, to move the y to the right. We're going to have to move this minus 11 to the left. So if I move the y to the right, that's 5x minus y minus 11. And that's, again, if we take the y over from the left, there's now nothing on the left. So that's equal to 0. Now I want to move this number to the right, as I said. So therefore 5x minus y equals 11. Now if we look at both of these equations, they are both in the correct format. I'm now going to put it back in the correct in the order that we normally see simultaneous equations in, which is 2x minus y equals minus 7 and 5x minus y equals 11. So you'll recall how we described this last year was we said that think back to primary school when you would have done addition or subtraction and how you would have done that. Say if I had 15 minus 7, you would have said for that, okay, I have to subtract the bottom from the top, so I get 5. You're kind of going back to primary school methods on this one because you're working from top down to the bottom. Okay, the aim of the game really is to get rid of one of the variables, so we're going to try and get rid of the y. And that's how we can solve for x and solve for y. So to do that, what we have to do here is multiply one of these equations, the top or the bottom, by minus 1. Because we want either we want these y's to cancel. In other words, we want them to be equal to 0. So what I'm going to do here is I'm going to multiply the bottom line by minus 1. The rule for this is I multiply everything by minus 1. Okay, so that we're not changing the first line to x minus y equals minus 7. That stays as it is, but we are changing the bottom line. Minus 1 multiplied by 5x, that's minus 5x. Minus 1 by y, or minus y rather, that's a minus by a minus is a plus, equals minus 1 by 11 minus 11. Now, you should recognize an important achievement at this stage, which is we have a minus y and a plus y. But should we know that at this stage we've done it over and over again, that minus y plus y gives you 0. In other words, it cancels. So I've cancelled the y's. I now only have one variable, which means I can work out the value of x. We have 2x minus 5x. That is minus 3x. Equals minus 7 minus 11. So again, if we think about this in terms of degrees Celsius, if it's minus 7 degrees Celsius outside and it decreases by minus 11 degrees again, it becomes minus 18. If minus 3x's are worth minus 18, we're now going to have to divide across by minus 3. So x equals minus 18 over minus 3. X is equal to, if we look at this, x is equal to minus divided by minus is a plus. So we're going to have a plus number anyway, and we're going to have 18 divided by 3, which is 6. Okay, that is the first stage of this junior cert question. Now you can see here, it's a little bit harder than what we're used to. If you go back to the original layout of it, it says find the point of intersection. So that's what we're trying to do at the moment. I have got the x value, and you know for a point of intersection you've got to have a y value also. So you want an x and you want a y. So how do I find the y value? Well, what you need to do here is you need to substitute. So we know this x value is equal to 6, but we don't know the y value. What I can do is I can pick out any one of these original equations. So like equation 1, equation 2. I mean, technically you could choose this equation here as well, and substitute in and see, can you find the y value? So I'm looking at these equations here and I'm saying, okay, this one looks the easiest. So let's write that one down. Y equals 2x plus 7. Now, to solve this one, I have to substitute in my value of x. So therefore, y equals 2. Now I know x is worth 6, so I'm going to put bracket 6 plus 7. Now if I didn't put brackets, that would be 26, and that would make no sense. So 2 bracket 6 is what we put in. Y is equal to 2 bracket 6, or 2 bracket 6 is 12 plus 7, so therefore y equals 19. The value of my coordinate here is x comes first, 6 followed by 19. So the answer equals 6, 19. This is the x value and this is the y value. Now you could technically draw this on the graph if you'd like as well, and you could solve it that way too. That is simultaneous equations, so a very quick summary on what we did. We were asked to find the point of intersection of the following two lines. So we have an equation of a line y equals 2x plus 7, and we have an equation of a line y equals 5x minus 11. We recognize here that this looks very similar to what we did last year in simultaneous equations, but the order is wrong. We normally have a situation where the x comes first, followed by the y that's equal to a number. So what we have to do here is we had to swap around the order. We decide that we're going to put the y next to x, we're going to put the number on the other side. And that's what we did here. We said y equals 5x minus 11, and we wanted to move that y, so that's 5x when it goes over an equal to sign, changes to minus y. And the minus 11 was here already, so we're going to leave that until the next stage. We then, in the next step, move the minus 11 to the right. So now I have finished this one, 5x minus y equals 11, and that's in the correct format here that I'm going to use. I did the same over here, and then you can see the rest of the steps in front of you. Okay, so hopefully that cleared up simultaneous equations for you. There is one final question I would like to practice here as well today, and that is this one. Okay, is the point 210 on the line L, so the line is called L, and we have the equation here which is y equals 3x plus 4. It says justify your answer. Now to justify your answer, really how do we justify this one is we're going to use maths. So I'm going to write out this equation, y equals 3x plus 4. Now, they're basically testing how well we understand this whole topic area. It says the point 210 is it on the line or is it not on the line? The way to prove that is label your coordinate, x, y. Okay, so x is always the first number in the coordinate, y is always the second number in the coordinate. And what we're going to do here is we're going to substitute. Now, if this coordinate is on the line, the way we will know it's on the line is if the left of this equal to sign is equal to the right of the equal to sign, and then that proves that it's on the line. If it's not equal, it means it's not on the line. So let's see what the story is with this one. Let's replace the y, 10 equals, and we have 3 bracket x, so therefore x in this case is 2, so 3 bracket 2 plus 4. So therefore 10 equals 6 plus 4, 10 equals 10. Now, as I said, if the left is equal to the right, then that means it is on the line. Okay, and this justification, you've done enough here in justifying it through the maths. Okay, rather than guessing, you have shown that 10 is equal to 10, therefore that means that this is on the line. If you had something like, for example, 6 equals 10, and 6 is clearly not equal to 10, so therefore it would not be on the line. Okay, I hope that has cleared up that one there as well. So those are 3 different types of questions I would expect are guaranteed on your junior cert in June. So hopefully now you'll be able to have a good go at those. I'll be assigning questions again, just 2 short questions for you guys today again.